Um, so I'm pleased to have Matthias Kawski lead the final session of the day, final math session. Take it away.
Okay, just a moment. I still one missing. Can you see me?
Yes, I can see.
Can you know this lady?
Yes.
Very famous math student. She was in one of the first math circles 8 years ago. Charmaine Seaton from Canada. And we have stayed together for a long time. Right now, she is in my class in the 3rd year or 4th year, studying advanced calculus with me, doing really well and getting a degree in biomedical engineering. So I hope that we're gonna get many more of your children, little young students, to come and be as successful as Jermaine. So what I wanna do with you is first introduce myself briefly. My last name is Matthias Kawski. I'm from Germany, but it's a Polish name. And if you ever wanna get in contact with me, if you Yahoo me and you just type Kawski, then you get motorcycles and lawnmowers. That's kind of funny. But that one is actually a way that you can remember my name. My name is Kawasaki with a few A's missing. And if you go to Yahoo, or instead of Yahoo, you Google me, you're gonna find me right at the beginning, and you come to my homepage, and I have lots of materials out here. And in particular, all the files which I'm gonna work with you today are on today's date. I have a listing of a number of Excel spreadsheets and other things. So if you want to get to those, they are all listed in here. I don't see many of you with cameras on. Yeah, now I can see some of you. That's much better. So what I would like to do is I wanna discover some nice patterns with you. And we're gonna play with them and do some nice colors. And I have done this one at all ages. So in particular, this one is one of the things which we hopefully gonna come up later with. Let me just show you what we are up to at the end. Woo! Do you like this pattern?
Wow, it's pretty.
Good. If I change this number to 11, looks like that. And I had handouts like this one for my students, and I asked them to pass them around, and we wanted to know how the different patterns arise.
Nice.
And they were fighting over each other. They were fighting over each other. And I just said, please pass them around, pass them around. I said, no, this one is much prettier. And they said, I want to have the pretty one. I want to have the pretty one. You can have that one. And then at the very end, we put them all up on the floor in the front of the classroom and sorted them from the prettiest ones to the ugliest one. And my second graders at that time discovered some amazing thing. Depending on what number I have up here. Is this one a nice pattern or not so nice? Let's take a 7. So they were fighting over this one, and they came up with some amazing result, which I did not know what makes pretty things. But let's start the way we did it the first time. And those were really young students, and I loved the way they were jumping up and down. And everybody wanted to be on the board, and I hope that you're gonna share your screens. And so the way I went into the classroom is just, I say, can you read this?
X, O, X.
No, there's a different way of reading that.
Hugs and kisses.
What is it?
Hugs and kisses.
So this one is.
I think that was kisses.
Kisses, hugs, kisses.
Hug, kiss, hug. Yeah.
Good. Do you have to do them in that order?
No. Or yeah, actually. Usually it's XOXO.
But we could do it in a different order. Let's try that. What's a different order?
O.
Hug,
Hugs,
hugs,
kiss.
XO.
Or XXOO.
Or little O, big O. Just kidding.
Okay, so I have hug, hug, kiss, kiss. Another one.
Kiss,
Kiss, hug, hug.
hug. Yeah.
How many are there? Let's try.
Hug, kiss, hug, kiss.
Hug,
Could
oh,
go.
hug,
you could-
kiss, hug, kiss. I like that. I put it up there.
You could go kiss, hug, kiss.
Kiss, hug, hug, kiss.
Or hug, kiss, hug.
What else?
Hug, kiss, hug. Oh, we already got that.
Kiss,
Sorry.
hug, hug, hug.
What else?
Hug, kiss.
I always had 2 hugs and 2 kisses. 2 X and 2 O.
Okay.
Let's look at some of the patterns in here. Do you come up with Can you see some patterns? How many of them start with an egg? Start with a kiss?
3.
3,
How many start with a hug?
3,
How many
3.
end with a hug?
3.
3.
How many have a kiss in the second spot?
3.
3.
There's a lot of 3s in there, lots of 3s, agree? What about the first 2? What do they have in common?
They're negatives of each other.
Yeah, I don't say negatives, but they are just flipped mirror images or something like that. Good. Do you think that we got all possibilities?
Yeah.
Yeah. So when I have something and I had one missing like this one, I wouldn't quite trust this one because there's 3 which start this way and 2 which start that way. That wouldn't look right. These ones are mirrors. This one are mirrors. This one doesn't have a partner. So I'd like you to look always out for patterns like this one. One of my students came up and just said, that's not enough. I don't like just to have 2 kisses, 2 hugs. I want to have 3 kisses. 3 kisses and 2 hugs. Can we do the same thing and try to find out how many possibilities there are and find them all out?
Sure.
So what I'd like you to do now is, and this one is the beginning to get to this beautiful pattern, is we have 3 kisses and 2 hugs. So X, 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 hug, hug. We want to find all possibilities. And I think the best way is to do this one in small breakout rooms.
Matthias wants to continue. You're muted, Matthias.
So when I did this one for the first time in school, I did it with very, very little children. I've never taught them at that level. And it was I was so scared going in the classroom, but they were just so fantastic. And I just said, why do I teach university? I should teach little kids. They are so much more fun. And so they all wanted to contribute their hugs and kisses, and everybody was running to the board and they put in all the names in there. Then I had them first I had them work in little groups in there, and they checked with their neighbors, and they were competitive on who can find the most one. Some of them found 12, 13, 14 But then their neighbors said, no, you doubled up. This one is twice there. You didn't get this one. So who got the most? How many different combinations did you get?
I think our group only got 9. Oh, 10. Nice.
We got 10
10?
possible.
10?
It was 3 kisses and 2 hugs, right?
Yes. 3 kisses and 2 hugs.
We got 8.
8,
12.
12.
got
11.
Good.
9. 10.
Let's actually do this one together a little bit. The way I like to do this one is, let me start sharing my screen here again. Share screen. And fourth thing is, this one is what we had earlier, 2 hugs and 2 kisses. But I did not write them in just some arbitrary fashion. There's some pattern to this. Can you see the pattern?
Yes.
What is the trick in there?
Three of everything.
Yeah.
Looks like you move the O through the top, like just changing position.
Yes. Yes. So there are lots of different ways.
Of the bottom.
Yeah.
Our group, one of them solved it like that. She put it in order like that.
Yeah, wonderful. Does anybody still use a dictionary?
No.
What?
Dictionary, where you look up words in which order they come. So we call this one the lexicographical order. So if you think of them as A's and B's, which word comes first? You have O comes before X and O becomes before OX.
Right.
Good, so this one is the order in which they come in the alphabet. Now, if we have this one, if these ones are all the solutions for 2 kisses and 2 hugs, what's the easiest way to get 3 kisses and 2 hugs from these ones?
3 kisses, 2 hugs.
At the X at the beginning or the
Or
end?
the end, right.
Yeah, so I just put an X at the beginning. Let me do this one here. And so without much work, I can go and get all the ones which have an X at the beginning, and then I have 2 more X's and 2 more O's to share. Agree?
Yes.
But this one only gives me all the combinations which start with a kiss. Now I want to get all the ones which start with a hug. How many possibilities do I have for putting a hug in the front?
5. I know.
4.
So if I start with a hug,
I got 5.
maybe 5.
Yeah.
If we have a hug in the front, what do I have to split up here in the back so that I get 3 kisses and 2 hugs? I need 3 X's and 1 O. Agree?
Yes.
Good. And so I can put the O in the front or move the O all the way across. And I actually did this one here. And these ones are my 4 combinations.
Yep.
Good. So all of these ones have 3 kisses and 2 hugs. But I can think of these ones with 3 kisses and 2 hugs. They come from what? They come from putting a hug in the front and then looking at all the possibilities that I have 3 kisses and 1 hug. And you said that you think of these ones as coming from moving through this picture. Let me see. I'm gonna organize this one a little bit better.
Can I add something?
Yes, please.
For the 0 up front, I had 5.
What is
I
the,
mean 0. I mean O. I mean hugs.
yeah,
So I think you missed OXOXX.
once more? Which one do you say?
OXO. Oh yeah, you got it. Sorry.
Good.
I found it. Thank you.
So what do you think how many we have total? So we are looking at all of those which start with a kiss at the beginning. They start with a kiss at the beginning, and then we have the choices of 2 hugs and 2 kisses in every order. And we already have figured out that that is 6. Agree? And then we have all of those where we start with the hug at the beginning, and then we have 3 kisses and 1 hug. So this one is the 3-1. This one is the 3-2. And this one was the 2-2 pattern. Agree?
Yes.
Good. So what I want to go a little bit further with is, no, this one is not the right one. So I can think of those which have these ones in here. I can again split these 3 and 1s up. And where do they come from? I can look at all of those ones which have a hug at the beginning. And if I have a hug at the beginning, how many choices do I have for 3 kisses? There's only 1 choice. Agree? So this one is the 3 and 0. Or I can think of it, I'm starting with an X. And if I'm starting with the kiss, then I have how many choices for 1 hug and 3 kisses, or 2 kisses. Can you see this pattern? So to get to this table here, I'm looking at the 1 choice of 3 kisses and put a hug in the front, or I look at 2 kisses and 1 hug and put another kiss in the front. Good, so I get 3 plus 1 is 4. And then I get 6 plus 4 is 10. Can you see the pattern?
Yes.
Good, so I'm always getting the ones which I have on the left and I put an X in the front, or I'm looking at the ones above and then I put in a hug in the front. Can you see that pattern?
Yeah.
Good.
Yeah.
One is I'm going to start with a row of 1s and a column of 1s. Yeah, you have paper, you're working with me? And the rule should be that in this table, we are always taking for each spot the number on the left and the number on the right and put them together. So if I have 1 and 1, I get
2.
2. If I have 1 and 2, I get
3
3,
and
4,
4.
5. That was easy. Okay. What about in the other direction?
3.
3, 4,
Good. 1 and 5, 4 and 1.
6,
Good. What do we get in here?
4,
3 and 3 gives me
That's
4.
6.
Oh, 8.
6.
6. 6.
You're funny.
Oh, yeah. Okay.
9,
9.
6. 6.
Okay.
10.
9, 12, 15,
15.
11,
15.
12.
Okay, you keep writing this one.
Oh, 21.
18. 21. 21.
21.
20.
No.
Hope. Hope. There you go.
35.
21.
10, 10 and 10 is
20.
20.
35.
35.
46. I mean,
Oh dear.
35.
35.
70.
56.
oh, the numbers get big quickly. Agree?
Uh-huh.
Good. So I did not know how big can second grader handle numbers. How big can they add them up?
3 digits.
3 digits? Yeah, that's what we got. So we came to 200, 250, and then they stopped and just said, this one is getting too hard. This one is getting ridiculous. The fun part which I did with them is just that I don't have enough space on this table. Let's forget about all the tens.
70, 80. 60, 70.
So we made our table and continue, but we forget about tens and hundreds. Just erase them. Just erase them. And my kids looked at their teacher and said, "Can we do this one? Can we do this one?" And I told the kids they have to look at me. I'm the boss, and I can make my own rules. So what we did then is basically, if we are forgetting about the tens and the hundreds, then we have 1 and 7. What is 1 and 7 give us? 1 and 7 gives us
8.
8.
8 and 6 gives us
14.
4.
4. 4. We don't care about the tens. Good. So what we did is we actually made the table pretty big in here, but since we only have 8 minutes left, I'm gonna use some technology on the side, and I'm gonna do this one with the machine in here. So basically this one is the table. We didn't quite get to this one as quickly as possible. Let's make this one no, this one is the right size. Good. So this one is, I only have a 10 in here for special reasons for programming.
So she has to have her cradle board.
Mm-hmm.
And the first time it really ends like right here. See? Yeah, where this is at. And
You're
we extended
now
her
you're telling
mattress
everybody a story.
Okay.
If you're a host, you can go ahead and just mute everybody.
So Matthias, I unmuted it.
Oh no, he's muted now.
Unmute you, Matthias, because I muted everyone.
Good. So what I would like to do is, can you find the annotate button on your screen?
Yes.
There's an annotate button, and what you should get up is a bar of different things in here. What I'd like you to do is select the stamp, and let's do this one collectively. And yeah, I'm gonna use my heart in here. And what I wanna do is, we wanna color this table, and we're gonna do this one with 100 students together at the same time, and Zoom is just fantastic for this one. So the first time that I did this one, it was really fun. There was a big sign hanging on the whiteboard, and it said even and odd, and I asked my kids, what do you mean? I'm not odd. They said that they were learning even and odd, and I just pretended that I had no clue. And then they came and wanted to show me what even and odd means, and they literally came up to the whiteboard, and we had these numbers on the table, and they were circling all the even numbers. So let's do this one. Everybody get a stamp, and together we're gonna spend 2 minutes to make all the even numbers stamp. Let's do this one together.
For 10 seconds.
Oh, I made a mistake. Dang it. Is 0 an even number?
In the pattern, yes, it is, but it could be an odd also.
I think even means that's a multiple of 2. So 0 is 2 times 0. Good. So what I made wrong in here, let's stop this one. I apologize. I made a real stupid mistake. I should have asked us to color the odd numbers, not the even numbers. Dang it. Let's go back. I can do it in a quick way. So this one looks good. And I like this one on Zoom. That was just my idea last night to just say, I get you all active. We vote a lot with stamps. So I say, is this one right or is this one right? And then we vote and half the students pick this side and half the students pick that side. And we have lots of stamps in here. That works nicely. Let me go back to actually take this thing. Oh, I have to get out of this enable annotate thing and enable editing.
You can clear it.
Right now it looks nice. Actually, yeah, let's clear this one. So where's the clear all drawings?
Put it. Yeah, go back to annotate.
No, I want to stop this one. I'm gonna do it very quickly with you. No, Control A. Conditional formatting, color scales, and this one is fine. This one is the pattern which we should have gotten. So I just changed the numbers a little bit, but what we have is the red ones are the even numbers and the odd ones are the green numbers. What kind of shape do you see?
Triangles. Rectangles.
There's lots of I think they're mostly
There's
triangles.
right triangles.
Yeah, right triangles. And can you explain why these right triangles happen with red numbers? If you have an even number and another even number, what do you get?
An even number.
Even number. If we have a whole row of even numbers diagonally, then we get automatically a whole triangle. Agree?
Yeah.
Okay. So doing this table in Excel is really, really easy. I'm gonna put this one up in the chat later on in the files, and you and Dave will have a link for this one. Making this table takes me about 2 minutes, but what I'd like to do is change the numbers back here to 10. 10, hit enter. Good. So in this table, what we did last time is we just said, actually, let's give them all different colors as I have them in Excel. So in what we had on the board was this table. Oh, let's see. Control all. Control all. Conditional formatting. Clear the roots from the entire sheet. Good. And so what we said is, instead of just coloring the even and odd numbers, we should actually color all numbers. And if we annotate, how many different kinds of stamps are there?
6.
6. You cannot change the colors, but what I said is, let us take all the 3s. Let us take all the 3s and make them hearts. Is there another 3 somewhere? What happened to all the 3s? Yeah, all the 3s become hearts. Good. And then we can take a different stamp and say all the 2s become arrows.
Down here
So we're
at the bottom.
somehow I can't find any interesting numbers.
Bottom.
There's a 2. There's
Number
a 2.
8, number 6.
Yes.
7.
Good. So basically, this one is a fun interactive exercise. And if we have more time, or if we had planned better, we'd use 5 different colors. And what do we do with 6, 7, 8, 9? My students had the idea and just said, we start over again. 6 gets the same color as 1, 7 gets the same color as 2, 8 gets the same color as 3. Sounds good? And so I'm gonna close this one out and basically show you some of the patterns which you get. I clear all drawings. And I'm gonna go over to this sheet in here, go to the whole screen. And what I'm gonna do briefly is I'm gonna change instead of having a 10, so this one is what we did for the 10. So we get 10 different colors. If I take a 5 in there, I get this one. Oh, sorry, this one is wrong. There's a 1. This one is a 5. This one is if we only count even, odd, even, odd, even, odd. And otherwise we count, if we divide by 3, then the remainders can be 0, 1, 2, 0, 1, 2, 0, 1, 2. Does that make sense? So we're adding them together, but then whenever we get to 3, we start counting again by 0. And I have done this one with the kids, and I said we were passing them around, and let's see. And I want to have you discover some of this one in the last minute in here, and my screen is missing. So let's take a look at these pictures in here. Where's my camera not on? Oh, this one is a 2. Is it a nice pattern or not so nice? 2.
Mansa.
This one is a 3. 4. 4 is a little bit messier up here. 5.
Oh, that's nice.
6.
They look like Navajo rug textiles.
Yes, that's what I thought.
And then
This
if you
one is
put the lines of symmetry going both diagonal and horizontally, that would be a really nice rug.
Okay. So this one is a 7. I think that's a very clean picture. This one is an 8.
Whoa.
That's a mess. 9. 10. 11. What's special about 11?
Wow.
That's cool.
12. A mess.
Yeah.
Let's give time for what's special about 11. Put 11 and 12 next to each other. Because this came up in an earlier breakout room that I was in where somebody was asking what is and how do I do for my 5th graders, I think.
Wow.
So
11.
that was 11. This is 12. 13 13 I don't have. 14. 16. What a mess.
Wow.
17 is really pretty. What's the difference between 16 and 17? 11 and 12. 24. Wow.
Going back
26.
to the rug, is it because on the odd numbers you would be pulling 3 strings and the even numbers you would be pulling doubles? So that third one makes it a mess. and the other ones keep it even. I had to, it still does works with even and odd.
Yeah. Oh,
It's like
look
every other picture is neat.
Look
Yeah,
at this one.
numbers are
20
neater than the even numbers.
25 is an odd
Yeah.
number.
Oh,
25 is a mess.
Can you show 7 again?
That looks pretty.
I was gonna say, I like that one.
Yeah.
7.
7. Oh.
Oh, wow. I'm thinking prime numbers.
Yes. So what are the prime numbers? 7, 17,
9,
17,
Yeah,
23,
11,
5,
11,
19.
13.
13,
Okay.
17,
20, 23,
What is this one?
19.
What is 48? Can you factor this one into prime numbers? 2 times 24, 2 times 2 times 12, 2 times 2 times 2 times 2 times 3.
3 times 3.
Yeah, good. So this, I had never seen this one before, and I was in a class of second graders, and they were sorting them on the floor in front of the whiteboard and said, this one is pretty, this one is ugly. And the listing that they came up with was 2, 3, 5, 7, 11, 13, 4, 6, 10, 14, 8, 9, 12, 16, 32. Just by looking at what the patterns are. Cool?
Isn't this a nice description and introduction to prime numbers?
How many of you are familiar with Excel? Let me do this one really quickly. What I do is I type a 1 in here, then I block out an area and just say go to the right. I block out an area, I take this one down and go down to the undo, and I just say Control D. Control means roll it down, and then to do the whole table, all that I do is I go into this one cell and I type equal, up arrow, plus, and left arrow. Can you see? So I'm just hitting up equal, up arrow, plus, left arrow, and I hit enter, and I get the 2. And now I want to copy this formula down. So I block this whole area and hit Control R and Control D, and I have the whole table done. That's all the typing that I had to do.
Cool.
Good?
Wow.
And the only difference which I had earlier was that I put a 10 in here, and now I wanted to change my formula a little bit. And this one is the fancy command $1. So this one always, no, it's not A1. This one is my cell C3. C3. So what this one says that rather than always taking the number to the right and to the left, with the dollars say that I always will have this cell rather than moving it around. And then on the top, I put the command mod for modular arithmetic. It's after division by. And what this one does is whenever we get to 10, I divide by 10 and only keep the remainder.
Right.
And this one is the table.
Cool.
Yeah. So I have this one written out, and on the web, I have actually all of these tables available. So if you go to my web page, my calendar is up here. Today is the DNA Teachers Workshop, and all the files are here. And so here you can download all of them, and they are already pre-prepared.
Oh.
Good. So in summary, I'm a little bit over my time, but I hope that you had some fun. And what I like is we are starting with simple kisses and hugs. And then from the kisses and hugs, we come up with mathematical rules, and the rules make really cool patterns. And these ones are known as Sierpenski triangles, and that's the name of my session. Thank you all for your attention. I hope you had some fun.